One of the useful applications of KVL or KCL is when we have independent voltage or current sources connected in parallel or series. So I'll show you these two applications. So in here I have three different current sources connected in parallel, and I know they're connected in parallel because they do share a pair of nodes. Specifically, this is the first node and this is the second node. And remember, a node can be expanded or subtracted, so I could have just redrawn this into just a dot. But anyway, so what we can do is we can say, you know what, we can have an IT in here and just select this particular node, the red one in here, and just write the KCL equation here. So KCL tells me that I of t plus I1 plus I2 minus I3 should be, or equals I3. If like basically I1, I2, and the t are all leaving the node, while I3 is actually coming into the node. And by rearranging it slightly, you'll figure out that it becomes I of t is simply negative I1, negative I2 plus I3. And I can substitute all of the three different current sources by a simple one current source, and that one here is simply I of t. So that's for current sources connected in parallel. We can do similar analysis for voltage sources connected in series. So I can substitute all these three voltages that are in front of me, or three voltage sources, by a single voltage source. We'll call it VT. And the way we can do it is by saying, okay, well, we can put that this is plus and this is minus, and I'm going to call this node as A, and this I'll call this B, and this becomes in here, this is VA of B. And then what we can do is we can create a loop in here, and in this particular loop we'll use KVL, and KVL tells me that becomes VAB. And then of course this, because we hit the positive first, and then we can actually go in here, that's negative, positive, negative. Okay, so that's basically negative V3 plus V2, negative V1 equals 0. We rearrange the terms a little bit. The VAB, or V total, if you may, equals V1 minus V2 plus V3. And you can substitute all of these in here by saying this is plus, this is minus, and this is simply VA of B, and this is what we found in here.